Hey everyone, joining you from home. I might be talking a little softer than I normally do, and there might be a cat, my kid's cat, not mine. I don't claim it, jumping, but I had to come home early today. But anyway, I'm making this video for you. I'm stalling because I need to share my screen with the work. Let me find it. Boom, this is the last test, except for the exam of semester one. So basically, by the end of this test, most of you will have already passed semester one. Um, that's pretty awesome. So well done. Let's get into it. I think we're recording. I am definitely recording. I am definitely sharing. Definitely have the full screen. Okay. Oop, I need that back though. Okay. Here we go. So make sure you practice and use this just like you have before. Um, for the test, for Friday's test. Vertical asymptotes. Okay, vertical asymptotes. Vertical asymptotes, we need to make the denominator, denominator equal 0. Okay. And then for x-intercepts, we need to think, okay, if there's an x in the numerator, if x in numerator, make that equal 0. Okay, so I'll try to remember to do them in separate colors. Okay, so the vertical asymptote for this line, vertical asymptote, I take the denominator and I say, hey, x minus 1 equals 0, which means it's just like solving for zeros with quadratics or with our the polynomials and end behavior that we were doing, right? So that means that x equals 1. Okay, we have an x in the numerator. So we say the x-intercept x plus 6 equals 0, which means that x needs to equal -6. Okay, now just to be clear of what this means, right? That means that this x equals 1. Okay, so if we had a graph here, it would come very close. It would come very close to where x equals 1. It would not touch it. Right? It would come very close on the other end as well. It would almost get there, but it would never touch that line of x equals 1. So we're basically, when you have x equals, right, it creates a vertical line. So x equals 1 is where that would happen. All right, I'll go faster through the other ones, but wanted to make sure on that first one, you guys knew what was going on. All right, 55 minus x, a little tougher here. So 55 for the vertical asymptote. 55 minus x equals 0. You could either do this one step or two steps. I would add x to both sides. So then I have 55 equals x. If you decided to do it two steps, if you did 55 minus x, because a lot of people are just used to taking that 55 away from both sides, you would still get the same answer. Negative x equals negative 55. That means positive x equals positive 55. So vertical asymptote there, and the x-intercept, there's no x on top, so there is no x-intercept to worry about. Okay, right here, vertical asymptote, again, take 25, take x away, equals 0. Add x to both sides, add x. So now you have 25 equals x. that is my vertical asymptote again. It's just the number 40 up here. There's no x's there, so we would just say no x intercept. Here for the vertical asymptote, again, why am I making the vertical asymptote? Why am I setting that equal to 0? So if you divide by 0, right, if you make your denominator 0, that means you're dividing by 0. Can you divide by 0? No, you can't. It is undefined. So what we are doing is we are creating a scenario where our denominator will be 0 because that will break the math, essentially. We're saying this is where stuff cannot exist. All right, we've got another x-intercept here. X plus 3 equals 0. Take 3 away from both sides. So at x equals -3, we would have a x-intercept. It means basically that it wouldn't exist in that one tiny spot. All right. Now you might be wondering, well, where's the equations here? Okay, so I'm asking you to look at these and be like, where does this exist? Go to 3, right? That line gets very, very close. Very, very close to 3, but it never really exists there. So if you draw that line, that vertical asymptote, we say that the vertical asymptote was at x equals 3. This vertical asymptote, again, this green line, it's getting really, really close to right here. I'm going to be a little to the left so we can see the number there. It should have been exactly on that line, but I moved it so we could see, you got to think to yourself, what x value am I crossing? That is basically saying that x value is not going to exist in this function. So you guys can hear me. I know I'm speaking soft, but even if you can't, follow along with my work and you should be all right. We'll get to these after spring break before the exam. They're not too bad. Do these quick. I don't think anything on the test will be like this because of this will be after spring break as well. Basically, we're saying, okay, how do you get rid of a square? You use a square root. So we would say x equals 11 right here. Okay, divide by 2. That gets rid of the 2 right there. And you have 49 equals x squared. Well, what's the square root of x? Same root squared is 7. Okay, but we don't have to worry about that too much till after break. All right, factoring here. Okay, so let's think what multiplies to be 6. Multiplies. So we're using a reverse box method, basically. They're saying what would multiply to be 6 and add up to 5. Well, that's 3 and 2. I'm writing this box. You didn't have to do the box, but it proves what I'm saying, that this would create this. Okay, but this says to solve, right? So once you have those factors, x plus 3, basically taking standard form, turning it into factored form, and then taking those factors and creating zeros out of them. So if if the factor is 3, the zeros, x plus 3 equals 0. A lot of you can do that by just visualizing it, just showing this method so you understand where these answers come from. So what I gathered from this is that this is a parabola that crosses at -2, -3, and has a y-intercept of 0, 6. Okay. This next one is asking me to multiply to be negative 12. Okay, that's the number we need to multiply to be. And then it needs to add up to positive 1. So think to yourself, what multiplies to be 12 and it's 1 apart from each other? 4 and 3, right? They're 1 apart from each other. When you add them right now, it would be 7, and it would multiply to be positive 12. I need to make this multiply to be negative 12, so I need to turn one of them into a negative. The question is which one? The one, because they're going to add up to be positive 1, I need the larger number of the two to remain positive. I need, when they go together, that I need to say, hey, I have more positives than I do negatives. So 4 would be positive, 3 would be negative. So this in factor form would be x plus 4, x minus 3, which means my zeros, x equals negative 4, x equals positive 3, the opposites, right? And we got that the same way we would solve there, but I did it just mentally in that case. Okay, quadratic formula. Take a deep breath, realize you have the quadratic formula with you, okay? Look at your quadratic formula, okay? You're gonna need A, you're gonna need B, you're gonna need C. The first thing we're gonna do is use those things. Well, we got 1, 7, and 8. But I wrote D there because we're going to first find the discriminant. Look at that part of your formula sheet where it says B squared minus 4AC. Okay, so B squared, that would be 7 squared minus 4. A is 1, C is 8. 7 squared is 49. 8 times 1 is 8. I'll rewrite this again. 49 minus negative 4 times 8 is negative 32. 49 minus 32. Oh, we couldn't give you an easy one, huh? We gave you a tough one. Is 17. Here's why it's kind of tough. Because square root of 17, I don't need that big decimal number. Just leave it as a square root of 17. Okay? You might be thinking, well, that makes it really tough, but it actually makes writing your final answer a little easier. Okay? Because I'm not looking for you to divide the square root of 17 by something. Okay? I want you to find the middle of this parabola, which would be the opposite of B. Opposite of 7 is negative 7 over 2a. So 2 times 1 is 2. And you're going to add and subtract root 17 over 2. And you're done. That's an A answer right there. Nothing else has to happen. It might look like a bunch of complicated stuff, but that's basically saying, hey, I have the middle of my parabola is at 3.5, which is 7 over 2, negative 3.5. And I'm going to take this weird number, which is root 17 over 2. I'm going to add that, go to the right to find one answer, go to the left to find the other. Okay, so either of those two ways to write it would give you full credit on that problem. All right, this one looks complicated because we're missing something that we normally have, but there's actually a part of it that makes it easier. Okay. All right, so we've got A, it's 2, B. So remember, it's A x squared plus B x. Ah, the wind is blowing in my hair out of here. Plus C. B is not the second number you see. B is the number that is in front of the variable x all alone. Okay. Is there any number in front of x all alone, like we had with 7 on number 17? No, there's not. So b is actually 0. What that tells me, my b of 0, that tells me that the middle of my parabola is going to be on the y-axis. Okay, well, I'll show you that here in a second. C is 8. Okay, so it doesn't make finding the discriminant easier, but it is going to make finding our final answer easier. All right, so let's get that discriminant, by the way. So b squared, so, well, I guess it does make finding the discriminant a little easier. B squared, so 0 squared minus 4. I'm acting like I have to write all that. That's an 8, by the way. Okay, so 2 times 8, 16. 16 times negative 4. Negative 64. Okay. Square root of that. Just think of, okay, we can't take the square root of a negative number. Okay. So take the square root of the positive version of it, which would be 8. An I next to it, which means it's imaginary. Okay. So put 8i there. So the opposite of b, so negative 0 over 2a. So a is 2, so it's like saying over 4. Plus and minus 0 divided by 4, by the way. It's not undefined like before when we divided by 0. Dividing into 0. So that's just saying the middle of our parabola is at 0, which means we're on the y-axis. Okay. And then we're going to add and subtract 8i over 4. Now, if you left it like that, I'd probably actually give you a minus on this part. Okay. X equals that. Now, if you realize that 8 divided by 4 is 2, right? You could just say that this answer is X equals 0. So you don't need to write the 0. You could just say positive and negative 2i. Because 8 divided by 4 is 2. So it seems very complicated. I don't want to make it seem like it's easy or anything, but really think about if you had a parabola and that parabola was x squared. Okay, let's say that parabola is x squared. Okay. Now, let's look at what we have. 2x squared plus 8. So it is twice as steep. I'll make this one blue. Twice as steep as this parabola. And it has a y-intercept of 8. But it didn't move to the right or left. You know, nothing's happening to it. You're just making it steeper and moving it up 8. So the middle of it, like we said, is at 0. That's what 0/4 would represent. Okay. And then you're not going to touch the x-axis because you moved up. You moved up from the original x-axis. So you're floating there. And what we did with our 2i is we're just basically saying, okay, one of those imaginary solutions would be here, one of the imaginary solutions would be here, but we don't actually cross that x-axis. All right, use an algebraic method to find all values of x that make the equation true. That's just saying solve, okay? Use an algebraic method. So technically an option is factoring and quadratic formula. Those are our options. Okay. So what multiplies to be 2, negative 2? Is there anything that multiplies to be negative 2 that's going to add up to be 1? Okay. Well, you've got 2 times 1. That's really our only options. Are those one apart from each other? Yes, they are. Okay. So -2 multiplies to be 1. So we would need this to be positive, this to be negative. I'm not so confident in this. I don't know why, but it's throwing me off. So I'm actually going to say, hey, is x plus 2? I'm going to check my work here. X plus 2 times x minus 1. X times x is x squared. 2 times x is 2x. -1 times x is -x. -1 times 2 is -2. Add those up, and you get x squared plus x minus 2. Okay, so I could factor here. X plus 2 and x minus 1 are my factors, which means my zeros are x equals -2 and x equals 1. It says use any algebraic method. So in class, if you would rather do this with quadratic formula, let's do that in class. I hope we're to a point where we see that and we would rather factor because it's a much easier or a faster process if we can do it that way. Quadratic formula would work, but I'll just take your questions if you want to on that part. All right, which could be the graph of this quadratic? Neither. That's what's throwing me off. Am I messing something up? You know what? I'm going to check with the plus x minus 2. Am I missing something here? Could either of these be the graph? We have, my factors are, these should be switched, right? This should say -2, 0. This should say 1, 0. I'll double check this in class. I feel like something's going on here, or we changed something from the other test. Anyway. All right, last problem. Sorry about the hiccups on the previous one. Okay, cruise ship is going to travel 15 miles, planned speed of 20 miles per hour. Okay, so personally, what I like to do with this problem is make sure I know what this graph is measuring. Okay, so the x value here is wind speed. And the reason I like doing this is because usually, like 99 times out of 100, we measure time on the x-axis, right? But we are measuring time on the y-axis here because we're trying to figure out if the wind speed changes, how does that change how long it takes for us to go? And we're measuring it in hours. Okay, so what does T of 13 mean? So go to 13. Let's 10, 12, 14. So 13 is right. This would be 12. This would be 14. So 13's in the middle. So go right here. And the x value is 13. Check what the y value is. Halfway between 2, 4, 6, 8, 10. So that would be about 5, right? No, sorry, about 3. 2, 4, 6, 8, 10. So we're at about 5 here. So 13, 5. Right? So T of 13, we'll put an approximate there because I don't know if my line is exactly straight, is 5. So what does that mean? So T of 13 equals 5. That means if wind speed wind speed is 13 miles per hour. It takes the ship 5 hours to travel 15 miles. Okay. Okay. So, so basically the wind is fighting against us. The higher the wind speed gets, the slower the ship goes, right? It's fighting against us at this point. Okay. At what value of W does the graph have a vertical asymptote? So look at this line, how it's coming close to here. So I can see this visually on this graph is about, looks like it should be about 20. Okay, well, I can actually solve that mathematically. I told you I'd try to stick with these with blue. Doing a good job, aren't I? All right, so 20 minus W, make the denominator equal 0, right? So add, oops, sorry. Add W to both sides. So if we had a wind speed of 20, we would create a scenario where this ship is not moving. It's not moving backwards. It's not moving forward. It is absolutely still. This ship is going 20 miles per hour. The wind fighting it is 2, so it's making it stay still. Okay, so give that full explanation. What value does it have a vertical asymptote when W equals 20? What does this mean? This means ship and wind are at exact opposite speeds, and ship is still, like standing still. Maybe we'll put that standing still. And if you're standing still, you are never going to reach that distance of 15 miles. All right. Hopefully this is helpful. Ask questions if you have them, and we'll double check that one that was giving me issues earlier. All right. End the recording. End the recording.